Good afternoon, everyone, and welcome. Thank you for joining. My name is Julia Subko, and I am a data analyst and project developer at 81 Watts, the leader of communication and dissemination of UNICA project. Thank you for joining the UNICA webinar, The Future of Cancer Screening, Vision, EUCAIM Alignment, Fair Data and AI. Today we are joined by Michele Compare, UNICA Coordination and Chief Technology Officer at Datrix, Ignacio Blanquer, EUCAIM Technical Coordinator and Full Professor of Computer Science at UPV, Cinzia Cappiello, Associate Professor in Information Systems in Politecnico di Milano, and Elia Broggio, Data Scientist at Datrix. And let's move to our agenda. We will begin with the UNICA vision presented by Michele Compare. Please note that you can submit your questions at any time using the Q&A section. We will address all the questions at the end of the session during our Q&A discussion. And now, Michele, the floor is yours.
Thank you, Julia. Good morning, everybody. I'm Michele Compare. I'm the UNICA coordinator and CTO at Datrix. The motivation beyond UNICA comes from the dream of beating cancer. As you can see from the statistics available at the European Cancer Information System, elaborated also by GRC, cancer is still a leading cause of death in EU. We had less than 3 million new diagnoses in 2024 and less than 1.3 million of deaths in the EU. The good news is that the mortality rates are falling, which means that the actions in place are yielding some benefit. But of course, the absolute number of cases is rising mainly due to the age of the population. A key point to succeed in this fighting against cancer is to unlock the potential of medical imaging. On the one hand, we have the incredible progresses that the AI experienced in the last years, which offer a huge potential for improved screening and the early detection. But on the other hand, AI needs to be trained on large data sets. These data sets are available. There are vast repositories of imaging data, but these are currently siloed because every institution, every individual center has its own data set. So this vision fully matches with the EU response to beat cancer, because AI is a key pillar. One key challenge is the unlocking of the access to high quality data. There are other objectives such as the infrastructure, the building of the infrastructure, the extension of the applicability, the enhancement of the AI itself, and also the building of a strong AI talent base. And within this elaborated strategy, the EU, a European Cancer Imaging Initiative, funded the EUCAIM project. As you will see later, the objective of this project is to create a pan-European federated infrastructures of anonymized cancer imaging data to support the AI innovation. EUCAIM project is the elder brother of our project UNICA, whose mission is to increase the geographical reach of EUCAIM, so gathering data primarily from screening programs and opportunistic screening, specifically for lung, breast, and prostate cancer. The main objectives of our project are, for the first is to perform cancer data standardization by FAIRification, which will be explained later. Then, as we said, one other objective is to expand the geographical coverage and increase the data sets for UK for AI training. Then we need to be another objective is to be aligned with the other initiatives at the EU level, which we saw are on different from different perspectives. The other objective is to promote the patient empowerment, so make the patient more informed on what is going on from the research point of view. And finally, the other objective is to favor the AI adoption. And from this point of view, we have two main, as UNICA, we have two main final outputs. On the one hand, a tool that can assess the risk of breast cancer from mammograms, and the other one is to detect lung cancer from CT scans. So the idea is to have the hospitals, institution providing the data, the federated environment provided by EUCAIM, and with the development of AI algorithms that allow the our clinical partners to estimate the risk and improve the detection of lung cancer. The consortium is made up of 15 beneficiaries and one partners coming from 10 countries across Europe. In particular, we have the first row is made up of the technological partners, Datex, Politecnico, Università di Valencia, and 81 Whites. Then we have the clinical partners, which are, as you can see, two from Germany, three from Greece, three from Portugal, one from Slovenia, one from Poland, and Ukraine. And these institutions are expected to provide for breast almost 150,000 images. For lung cancer, almost 60,000 images, and the same for the prostate cancer. According, again, to the EU data, these three cancers are the most impacting on the health of the EU population, as you can see from these histograms. Giving a look at our project, it started in September 2025, and the end is scheduled by February 2029. So we are now at the end of the first 6 months. The project basically is divided into parts. The first is on the laying of the foundations, which means the work packages are more related to the agreements, to the building the collaboration with UKAIM and other stuff. So the second part is more on the building of the tools that we are committed to build. So after these 6 months, we have basically developed, we have already started with the UKAIM, the agreements with UKAIM, starting the collaboration and building the infrastructure to proceed with the project. I think I'm done. So thank you very much. I'll leave the stage to Ignacio.
Thank you so much, Michele, for the presentation. Thank you so much for inviting me to this presentation. So I'll try to have let me see if the remote control works. Should to. It is not working at this moment. Let me see if I can do it again. Yeah. So it seems so, right. So I have the challenge to present in 10 minutes the whole UCAIM project, especially with the part of the federation. So I'll try to pinpoint on the more relevant things, but I've brought a lot of information for you to digest and have further information about our project. So basically, we follow in two approaches: the approach of collecting the data that has been already obtained from European projects and other clinical trials and make this viable for further research, and also help new projects to organize the data that they are collecting. In this environment, what we have created is an architecture. They have a central hub that manages some of the central services that provides a general catalog, distributed processing, access negotiation to the data, and data discovery. And we provide two ways of collaborating, or two ways of providing data to UCAIM. One is through data transfer agreements that are transferring the data to the platform in cases that there is no capacity of setting up a federated node. And the other is to share the data directly from the data holder premises, provided that they have sufficient computing capacity and sufficient IT knowledge to do that. So I'll try to focus on this later. First, understand how the data is requested. How is the data user journey? We try to align with the European health data space, which is on the making, that provides basically the discovery of data through catalogs and federated search, in which you can understand which is the data that is available there, and then the request to the data through a process in which an access committee evaluates your application. So data is not fully open. I mean, it requires the process of analyzing the ethical and scientific and technical constraints. With this, we provide, when the data is granted, we provide two ways of accessing the data: through distributed processing and virtual research environment on secure processing sites, depending on the capacity of the centers and depending on the access criteria of the different data sets. So for this, you can access the data either through the distributed processing or in these virtual research environments, and I'll try to focus on these two later on the presentation. Right, so an important point for UNICA, and as the same that we are doing for the rest of the project, we are also working on a sister project, which is called Breast Scan, centered on the screening data from breast cancer. What we provide is a mechanism to have data sovereignty by the project. So we do not, we have a figure within our data request lifecycle, which is the data set responsible, in which the projects and the different data holders can be the ones that are informed in all the process of request to the data. We can streamline the commonalities on ethical analysis, and we pass off the request to the data responsible, so they take the final decision and prepare the data for the specific case. So we are in the process of UCAIM trying to combine effort and non overwriting or redoing any other activity. So sovereignty is kept at the level of the data holder that provides the data. So let me very briefly comment the technical details, and then I will go with more details on the user and data holder way of interacting. So the title of the presentation was setting up a tier 3 node. I will explain what it means. But in this complex figure, you can see that we have two layers. The layer of the central services, which is on the top, services that are provided by UCAIM, like a central catalog or of a data discoverability service, and components that are provided by the federated nodes. Everything that is on the line, that is on the dashed line on the bottom, are components provided by each one tier 2, tier 3 federated node. And you will see later on. Let me explain these tiers, which is a very important concept in the context of UCAIM. So we have 3 levels of interoperability at the level of the services. This is something for the technical guys. So first is the interoperability of the level of the catalog. You have a collection, and then you register it on the catalog. Second is the interoperability at the level of discoverability. You have this collection connected to the federated search, and when a user asks for a specific inclusion criteria, you can return the number of cases that fulfill this specific inclusion criteria. And then you have the level 3, which means that you can also provide computing at your local site. Then this tier level also applies at the level of the data. Tier 1 means compliance with the metadata model that we have for the data set. Tier 2 and Tier 3 means compliance with the data model at the level of the federated or the full, sorry, at the level of the searchable fields or at the full level. With this, one important thing, an important asset that has been developed in EUCAIM is a common data model with a hyperontology that defines different variables, different fields for 22 versions, 22 types of cancer, right? So you can find our common data model, we can find our hyperontology on these links and also in Zenodo. And there are around 4,000 classes defined in MCode and OMOP. So you can adapt them to be interoperable with the rest of the providers. So that's an important thing, and I provide the links there. So a data holder, which is the first step, how to link as a tier 3 node, has this workflow in which you have first an initial assessment as to evaluate which is the level of interoperability that you can achieve. Then you have to follow the ethical and legal constraints, prepare with the preliminaries is to get all the information and learning about how to use the platform. And then you select if you can transfer, you would like to transfer the data, you would like to set up your own node, prepare the data, ingest the data, and connect to EUCAIM. So this process, I will try to outline a couple of important things there. First one, 3 things. The data preparation. Data preparation means that you have to convert the data to the specific format that we support in EUCAIM. So one is the metadata of the data sets. Second is the data models for the searchable variables, and 3 is the full level. So we provide a set of tools to support this data preparation, to make the anonymization, to make the data quality analysis, to check the DICOM tags, and several steps, and they are available in the links that we provide there. This data preparation is either for data sharing and data transfer. When all the data is prepared, then the users can access or can discover the data. What we provide for the users, and you could be benefit for UNICA and other projects that are collaborating in this sense. We provide a catalog, sorry, that currently has 86 dataset registers. We have coded our metadata following the Health DCAT AP extension, which is the specification that is being coined for the European health data space, with some additional, with some additions to consider imaging data that is not well covered in Health DCAT AP. We provide a federated search engine that can gather securely and collect the number of cases of each place. We have this access request mechanism in which you will have all the projects can have a user and then are contacted when a request is done, so they can evaluate the request through their internal DAX and also prepare the data for that and unify a dashboard to have everything there. At the same time, we have e-learning platform with different courses for the initiation, for the advanced use of several of the services, and a help desk to interact with our technical, organizational, and operational staff. These are services that are provided for the end users and everyone that wants to connect there. With respect to the processing, and I will stop we'll give a little more of detail here. We have a federated processing environment, which is now on the prototype version. It will be demonstrated in our next review meeting on March 11, and it will be released in production, hopefully by the end of March. That allows to process the data without direct access to the data, without visualizing the data, coordinating the processing along the different sites in the platform. But what this is even more important for the researcher is that we also, in some cases, provide a virtual research environment in a secure platform. What does it mean? It means that the user connects to this secure platform in a virtual environment, so they cannot take the data out. It's fully kept inside the platform, but they have access to computing resources and also processing tools that they can run directly as if the data were in their own premises. This is a very secure and audited, so it fulfills the SPE regulations of the, they are not coined yet, but they will be defined that we are following all these specifications from the secure processing environments. Right, so I'll finish with the part of how to link as a tier 3 node to EUCAIM, how to provide a federated node that can be connected to this catalog, this federated search, and this federated processing, right? So we have written a data holders handbook. Initially, we wanted to have a very simple guide, but at the end, it ended up with about 40 pages, because the process is not that straightforward. And we also have a legal handbook to fulfill with all the legal obligations. Legal obligations are not simple because we are trying to fit the model of the European health data space, and we have defined the minimum documents that you have to provide and fulfill to ensure that you are compliant with GDPR, you are compliant with the IPRs related with the data, the Data Act regulations, and additional processes for auditing that the data is shared among the conditions that are covered in the HDS. Once that everything is there, for the data operability, we also provide ETL tools. So you can transfer, you can get the data and transform in our data model and ingest in your own federated node. We request that the data is stored in a set of tables, and also that the image data is stored on this hierarchical model of patient, study, series, images. For supporting this, we also have created a software for setting up your local node that is now on the open source. That is open source, and now it's on the first version available that you can download and install by yourself and set up a node in which you could have a catalog, a virtual research environment within a secure processing environment, the authentication system compatible with OEDC to connect to external services, a collection of applications, and a set of functionality. We will be able to extend in the short time to be fully tier 3 compliant and connect easily to our platform. So finally, just to end, for sustainability, we are not doing this as a project. This is a long-running activity, and we are setting up a European Digital Infrastructure Consortium, an EDIC, that will provide sustainability beyond the lifetime of the project, in which we have, at this moment, 16 countries that are supporting the action, with Spain being on the leading edge. And we hope that we will be able to set up by the middle of next year an EDIC institution that will take up of the activities of UK. So that's the end. So just to end, being able to, happy to answer any question that you may have. Thank you so much.
Thank you very much, Ignacio. And I want to remind you that you can write your questions in the Q&A section, and we will address them in the end of our webinar. And I am happy to welcome Cinzia. Cinzia, we cannot hear you.
Okay, can you hear me?
Yes.
Sorry, I cannot go back. Okay, sorry for that. Okay, so first of all, hi, so I am Cinzia Cappiello. I am associate professor in Politecnico di Milano. And so in the UNICA project, as you will see better with the idea in the next step of the presentation, we focus on managing the data and analyzing the data through federated learning. Since we are in an environment in which data should stay local, as already Ignazio explained, and in order to get better insight from the AI, we require a high quality and large data set. So our choice was to focus on having an architecture in which we can perform federated learning. In this way, each data provider can maintain his own data set, and so we can analyze really a high volume of data. Clearly, what we need for having the success of this kind of architecture, we have to harmonize the values of the data set across the different institutions. And because as it is reported in this example, you can see that we can have different fields, different attributes that are modeled in different ways. So we can have different languages, we can have different conventions, and so we have to align the data. What are we trying also to do in order to get this alignment is to apply to our data sets and to the data sets that we are considering the FAIR principles. FAIR is an acronym that is for findable, accessible, interoperable, and reusable. And so what we are going to try to achieve is that our data set are fair. And so looking at all these aspects, clearly these aspects are actionable with some technical strategies. So for example, so the data sets should be findable, as also in the UNICA project are. And so for example, in order to make a data set findable, you have to have a unique persistent identifier. And the important thing is that you have a catalog. You have a catalog in which all the data sets are explained with a rich set of metadata. So we can have technical metadata, so they are explaining how the data set is composed of, so for example, the schema, the owner, and so on. But we should have also domain-dependent metadata, in this case, clinical metadata, in which we are going to have some context-dependent metadata in order to describe the sources better and also recognizable by the users in this context. As I said, it's important to have a catalog for describing all these sources. In this way, the user interacts directly with the catalog and not with the sources. The sources are not really directly accessible. So I just find what are the sources that are better for my analysis. The second point is that the sources should be accessible. Look, that accessible doesn't mean public, but it means that we have some authentication mechanism in order to allow the user to access the data that they can access. And so we should also have, once that person has the rights to access the data, that so the access should be done by using standard communication protocols. And so in this way, the data can be accessible. Also, the accessibility is guaranteed by the fact that the metadata should be always available. So the users can always access the metadata. And instead, we should have a level of protection additional that is for the data themselves. The other point, so interoperability is a word that we already heard from the previous section, and it's important that the data are interoperable and the sources are interoperable because we have to put the data together. This means that the data and also the metadata you should use a shared and standardized formats, and also should use vocabularies. Look that also vocabularies should adhere to the FAIR model, so they should have a certain level of fairness themselves. And also the interoperability can also enable the linking between metadata, and this should be guaranteed for a better exchange and interaction of the data. Having interoperability, this enable cross-border analysis and also interdisciplinary collaborations. And the last letter of our acronym is for reusability. Reusability is quite important because the data should be reused also for future analysis and also diverse research questions. So the meaning is that I have a data set, but the data set has not been built just for one single analysis, but this data set can be reused. And in order to be reused, first of all, we should have as also so we should guarantee that we have high quality data, so we should have some data quality checks, and also we should have some metadata that are describing the provenance of the data set. This is quite important because once that I access the data sets, if I have provenance information, I know which kind of operations have been done on the data set, and I can also decide if the data set is good for me or not. So having provenance is one of the main drivers for also reusability. Then we also should have some data usage license in order to guarantee the reusability and the use of this data, and also the metadata should meet some community standards. And in the medical research, we need also to respect the scope of the informed consent. So the data should be reused, but we should also focus on some domains in which we have the consent to analyze the data. Clearly, so in order to, so we are going to consider the raw data, then we have to guarantee this FAIR principle, and then we have to move to the federated learning. And so in order to move from the raw data to the federated learning, we have this adoption of the FAIR principle process principle, sorry, and so we need to have a process to deal with this data. And clearly, we should, this process is not simple because we are going to ingest the data from different organizations. And so the different organization and so the different data set they own can impose some specific limitations or can give additional requirements. So for example, in the UNICA project, we have, for example, medical data, and in this case, we have to pay a strong attention to the privacy and how the data are used. With the images, we have to adopt further harmonization. And then since we are integrating also with the EUCAIM, we have also to follow their FAIRification standards to be aligned with them. And so we have to have a kind of process in which we start from the collection of raw data. We are going to have interview with the different organizations in order to collect their requirements or their additional limitations. And so we have to define a schema model. In this way, we can define and validate the schema. Then on this data set, we are going to run an ETL pipeline. We are describing also the sources that we have. And at the end, we are making the data available. In this case, we have verified data sets, and once that we have the verified data sets, we can run our federated learning code to get the insights that we want. And so with this, I finish my section, and I will give the floor to Elia.
Thank you, Cinzia. In this presentation, I'm going to provide an overview of what federated learning is and how we will use it to reach our objectives. First of all, I'm starting with the formal definition of what federated learning is. It is this decentralized approach to train machine learning models without the need to centralize the data. If you think about classic machine learning, or call it centralized learning, all the data set needs to be collected in one physical location and then trained on that physical server. So this comes with a high risk of data exposure, privacy breaches, and in particular, when we deal with patient data, this is a very sensitive topic. On the other hand, if you use federated learning, the data never leaves the hospitals or more in general, the local node. This is because the training is happening at each local node. So what is shared is not the data, but just the updates of the model. So this results with a global model that benefit from having diverse data while maintaining a secure environment. We can think about the federated learning workflow as a four-step process. The first step is the initialization. So starting from a global model representation, we send this setup to the local nodes. And they start with their local training, use their own local data. I stress again that the raw data stays local and they're never shared among the nodes. Then what happened at the third step is the aggregation phase, where the clients sends the updated model parameters. You can think of, for example, in the case of a neural network, of its weights. So these weights are sent back to the central service, and that performs an aggregation. And then, if needed, more iterations are performed to reach a better overall result. You can think about this as a sort of train station analogy. So we have our central station, which is the UKAIM platform, where a data scientist can send an analysis task using this train to each local node, which is an hospital in our case. So this analysis task is performed at each local node, and then we get back at the central station with the results of this analysis. And then this is performed again and again for more iterations. Of course, there are some benefits for using federated learning instead of centralized learning. The main one for sure is data privacy and compliance. So again, we keep the sensitive data locally without, let's say, they stay inside the hospital firewall. So only non-sensitive model parameters are exchanged between the various stations. From a data scientist perspective, these also increase the model robustness, because at different nodes, we will have having different nodes. This will increase the data heterogeneity. So we will benefit from real-world data coming from different patients, and this makes possible to have a less biased model and that generalize better in previously unseen clinical sites. Then also the efficiency of the computation, because it's distributed among different nodes. There are also some drawbacks coming from federated learning. The first one is data heterogeneity. as the data comes from different patients and different hospitals distributed across the European Union, they are inherently non-uniform because, for example, patient demographics, they may have different age ranges, ethnicity, risk profiles, but also from coming from different hardware vendors. So they may use different systems to acquire this imaging data. And also there are varying screening guidelines among different countries. The second one, which is the one that just that Professor Capello just discussed about, it's about the data standardization. So we need to standardize hospitals' data using FAIRification pipelines. And the last one is about infrastructure, as there are varying level of computational power at different hospitals. As Michele previously said, we are going to provide two AI pilots. There are two deep learning-based models. The first one is for the risk assessment of breast cancers from mammograms, while the second one is detection of lung cancer from CT scans. I want to highlight that we will not pursue a clinical validation during the scope of this project, but of course, once we will have a good feedback from the clinicians, we might think of going also for that way. And I conclude my presentation. I give back the floor to Julia.
Thank you very much, Elia. And we move to our Q&A session. Please write your questions in the Q&A section, and we will read them and address them. Okay, and we already have some questions. We will start in the order that we have received them. And the first one is, what is the definition of data set in terms of images when we talk about ongoing patient care? And what is the interaction between... Okay, let's go with just the one question, and I think maybe Michele could answer it. Yes, I can repeat it.
Can I ask for the first question?
Yes.
I'm not sure I can get the question, in the sense that data set is a set of images that you can use for training the algorithm. So it's a set of images. Not sure that I answered this question.
Okay, I think the question was asked during the Ignacio
Or maybe
presentation.
if it's more technical on the UCAIM side, I don't know.
Yes.
Maybe I can take it if you wish. I mean, in the context of UCAIM, we call it data set as a collection of medical images plus associated clinical data that in some way we give them as a citable object, right? So we want to have the data sets as something that can be cited in your research or cited in the innovation, and therefore are registered in the catalog with a specific metadata. We try to have versions for each one of the data sets, but it relates to, as Michele was saying, as a collection of imaging data plus clinical data that is in some way freeze at one moment. The second question, I think, is quite related also to what, if you allow me, I can take the second one with respect to the integration of the federated local node with the SPEs. So the point is, that's an important point, right? So everything should be performed through secure environments in the context of the European health data space. So what we have defined in UCAIM is that these federated nodes that will be connected at the maximum level of compatibility, this tier 3, must provide a way to connect to this federated processing. Additionally, I mean, of course, they have to be nodes that have secure guarantees where the data is stored there, and then all the connection is performed through secure protocols, and the data is encrypted at rest, and all the steps. In some cases, for example, the UPV node that we have, it provides both things, virtual access, like a virtual research environment with a graphical interface, and a service to process remotely. So, but the SPs are a must in any processing environment.
Okay, I think we can go on with the third question. Normally, the patients are asked to provide an informed consent when he is included in a dedicated prospective study. This is often too resource intensive when we basically reuse patient data from the past, since it means to ask the patients from the past. Do you need an informed consent in EUCAIM? Contrary, we can use patient data when all the data remains locally. In this way, I understood the federated infrastructure EUCAIM. Is that right? I think it's always the question to EUCAIM.
Yes, if I can take a bit, this one, that's at an important point, especially in the context of project like, I mean, UNICA, breast scan, all those that are collecting data from screening sources that have additional timestamps that could be added later on. If you have retrospective data, I mean, we try to work on anonymized data, and then we rely on the data holder that they have the permissions, the ethical permissions for this specific data, and we work on anonymization context. Anonymization, I mean, you know, is always tricky in the context of images, but we have the clearance that if the data cannot leave the platform and the data is properly de-identified, we can call it anonymized. So in these cases, I mean, we have to talk with the legal experts, but in several cases, we don't need this patient consent. Moreover, in the case of the HDS, this patient consent will be waived given some specific conditions, and also data minimizations. So it depends on the case, and there are legal procedures that have been defined by experts that know much better than me.
Okay, thank you. Thank you for answering the question. I think we can go to the next one, and I think it can be addressed to Michele. How much of the technical aspects would be aligned with the EUCAIM project? For example, would the EUCAIM asset be reused, or is it more of a knowledge transfer?
Of course, the EUCAIM provides the environment, that we will use for training the algorithms in a secured environment. But the idea from our side, from UNICA side, is also to add AI algorithms to more focused on our scope, which is, as we mentioned before, the development of a pilot for breast cancer risk, and the capability of early detection of lung cancer from CT scans.
Okay. Okay, thank you. I think we can go to the last question. What will happen with the global model? If you want to apply it to a clinical setting, you might need to provide the data if a notified body wants you to write. So how do you, in that case, provide the data? Elia, could you address this one?
Yeah, as I said, in our project, we will not pursue clinical validations. That will be the case. They might ask for the data where the models are trained. So yes, that is an open point, but this needs to be discussed, let's say, the next step. So for the time being, we are not there yet.
Okay, thank you very much. And for now, we don't have any other questions, but please, you are welcome to write questions to our speakers. that we will be happy to answer.
In the meantime, if you allow me, I mean, what Delia was saying is really, really important. I mean, and also the question, it is not only the part of the clinical validation, but also the certification of medical device, of software of medical device. I mean, this is a point that is being really a hot topic now, which is how to prepare the data, how to deal with the requirements that the certification authorities will have, because each DS is requesting the data to be deleted when the models are extracted, and therefore the this traceability and this request that medical device regulation entities have, also AI Act is pushing, is not viable. So there's an important debate on that, and the viability of the data once that the models are trained is something that has to be guaranteed to ensure that they can be properly used later on.
Thank you, Ignacio, for your explanation. And for now, we do not have any other questions, so let's wait just one more minute to give a chance to someone to maybe write the last question, so we could conclude the session. Okay, I can see that no new questions are added. And at this point, I would like to say thank you to all our speakers for your contributions. And I would like to also thank all the attendees for joining us. And we appreciate your participation. And have a great afternoon. I would also like to add that the recording of the webinar will be available on the YouTube channel of UNICA, as well as the website of UNICA. And you are also invited to follow us on LinkedIn. I have added the QR code so you can easily access it. And thank you very much to all, and have a great afternoon. Goodbye.
Thank you. Bye-bye.
Thank you. Bye-bye.
Thank you.
Thank you. Bye.